Hello, Assalamualaikum. My name is Amira Bashra binti Ahmad Dili, AA181656, and my partner is.
My name is Nashaila binti Chaili, AA181661.
Today we are going to present our final project, portable solar powered wireless doorbell.
Assalamualaikum. My name is Muhammad Haidi bin Omar. My matrix number AA180059. I am student of Electrical Engineering, Center of Diploma.
Hi, my name is Nashaila binti Shaili, and I'm going to present about introduction. Project background: portable solar. Small size solar panels that are easy to install and can be carried everywhere. Convert sunlight into electricity or heat. Content and assembly of photovoltaic cells. Cell is made up of thin layers of silicon. Photons are released and create an electric field between layers of silicon in each cell when the rays of sun hit the panel. For wireless doorbell, doorbell button contains a built-in radio transmitter. Transmitter sends radio signal to the receiver unit when the button is pushed. Receiver detect radio signal and activates a sound chip through a loudspeaker. For problem statement, many cases that occur in the neighborhood, such as calls by guests that are not heard. For wired doorbells, the position of the switch should only be placed in a designated place. Cable life should be emphasized, and there will be some inconvenience during maintenance work if damage occurs. Installation of wired doorbell are difficult. High probability of slight defects in terms of soil or cement surface during installation due to cable route. Use of voltage rating are 230 volt to 240 volt, waste of energy. Objective: to apply microcontroller to control wireless communication system. Next point is to build wireless doorbell using portable solar energy. To design a wireless communication system using radio frequencies. Project scope: using Arduino IDE software, voltage for the RF transmitter and receiver is 3.3 volt to 5 volt 5 VDC. Height level of sensitivity: sensitivities from negative 112 dBm to negative 95 dBm. Transmit power with a rating of negative 30 dBm to 10 dBm. Expected outcome: to produce a wireless doorbell prototype that using solar as power source. Wireless doorbell prototype apply microcontroller to control wireless communication system. To create a wireless communication system using radio frequency.
Hi, my name is Amira Bashira binti Ahmad Dili, and I'm going to present about literature review. For the literature review, wired doorbell system needs complicated wiring. Regular maintenance for the wireless doorbell is low. Early doorbells on record in the Victorian era usually work in one of two ways, and etc. Twist doorbells use a key light mechanism on the outside of the door that strikes a bell on the inside when twisted. William Murdoch installed the first mechanized doorbell in his home. Late 1800s mechanical chimes were made using a small bell, manually activated when a visitor pulled a chain or string. Electric doorbell invented in 1833 by Joseph Henry. Early 1900, expensive batteries were replaced by transformers. Early 1930s, Morse doorbell were loud electric buzzers. Centuries later, video doorbell can stream live HD footage from front doors.
For methodology, wireless communication in this project is implemented using RF transmitter and receiver pair. Arduino Uno is the main task that determines the logic state of the decoded output from decoder IC. Activates the buzzer once the desired logic state is detected. When the button is pushed from transmitter side, logic 0 will be detected by the encoder IC. The encoder IC, HT12E, converts the parallel data from its output to serial data for the RF transmitter module to transmit, while HT12D decoder IC is the counter part of the encoder IC. HT12E converts parallel data and sends series data to HT12D. HT12D takes serial data and convert it back to parallel data.
So here is the result and discussion. This is our schematic diagram. Uh, the output is LED and buzzer powered by solar. If the switch is pressed, the pin 13 will be high. The encoder HT12E will convert 12-bit parallel data into serial output, which is transmitted through a RF transmitter. The receiver will accept the output signal. The decoder HT12D will encode the output signal into parallel data. Therefore, the output pin 13 will be high, but the others is low. It's same as the input signal transmitted from doorbell. The Arduino board is connected with the output of decoder via pin 7. One pin 7 in the high signal, the LED and buzzer will turn on. It follow according flow chart. When someone press the switch, it sends the high pulse to the pin of Arduino, which is connected near the door along with the transmitter module. When this pin gets high, Arduino transmits data through the transmitter, and these signals are received by the receiver. The Arduino, which is connected to a buzzer and LED light, reads the signal, and when the desired data is received, the function is satisfied, and the code will initiate the function, the music will start to play, and LED lights up. In order to ring the bell or buzzer in this case, we need to push the button on the transmitter side of the circuit. When the button is pushed on the transmitter side, a logic 0 will be detected by the encoder IC. The encoder IC will transmit data serially through the RF transmitter module. The transmitted data will be received by the RF receiver module and is given to the decoder IC. The decoder IC then decodes the serial data to parallel data and transmit the logic 0 to Arduino. In the Arduino Unos, it is programmed such that whenever a logic 0 detected by the Arduino, the buzzer is turned on. Hence, whenever the button is pressed, the buzzer is turned on wirelessly. So here is the table. When the push button state 0 and the LED will low, then if push button state is 1, the LED will be high.
For discussion, the wireless doorbell implemented in this project is just a demonstration of the idea, but the idea can be extended to actual real-time wireless doorbell system. Since the mode of communication is RF, the range is considerably large than other wireless technologies. This project is to produce wireless doorbell prototype that using solar as a power source. It helps to save energy that would have otherwise been taken from the grid. Wireless doorbell prototype apply microcontroller to control wireless communication system. This project use RF transmitter and a receiver. RF module operates at radio frequency and the digital data presented as variation in the amplitude of carrier wave. It can create a wireless communication system using radio frequencies. For the conclusions, wireless doorbells increase the safety and security of your home as well as the comfort of your home. Because of their wireless nature, you are able to set up the speakers anywhere in the house. This allows you to able to hear when people are at your door regardless of where you are in your home. Since the doorbell camera can be used to monitor who comes in and out of your home, it allows you to keep track of what is brought in and what is taken out of your home. The doorbells give you a better sense of security, especially if you put them on all of the most trafficked door around your home. They allow you to pretend that you are home when you are not. They give you the convenience of being able to see who is at your door regardless of where you are in your home. Thank you.